Hi everyone, Chad here. Thank you for joining me. Today's goal is to be able to write a method to measure plates with the AKTA Go. Plate measurements are an excellent way to be able to measure a column's efficiency. They're so important, in fact, that I'm trying to do a method video for every single kind of chromatography system that I have access to. So I've already done a whole intro video about plates, so be sure to check that out if you haven't seen it already. I also have a couple other videos about blocks or reading unicorn instructions and just generally navigating the method editor if you're having some trouble following along with what we're doing today. But otherwise, I think this is really kind of an easy introduction video. This method will work with any column more or less, and I'll kind of show you what I mean about that as we go along. So for today's setup, we're going to be using the AKTA Go, and we're going to be using 150 millimolar sodium chloride on the A inlet, and then we're not going to be using any other of the other inlets, so you can just have those in water or something. And then we're going to be injecting 1 molar sodium chloride like a salt bolus using the loop. So with this method, we're going to be injecting 2% of the column's volume for the salt bolus. So depending upon the size of the column you have, you may need to use a super loop. All right, let's get started. First thing we're gonna do is just clean this up a little bit. I don't like this gradient window down here because we're gonna be writing this plate measurement this plate measurement method for an SEC column, so we're not gonna be using gradients. Let's turn that off. And then next we're gonna click on this button up here, which is to create a new method. Then I'm just going to select the system that I want to use, and that's going to be an AKTA Go. And then I'm just going to use the empty method. Okay, all this says basically is that if we're using the phase properties to write our method, then we have to be careful what kinds of changes we make to the text, but we're just going to be using text, so we don't really care about that. Okay. So the first thing we're going to do is select a column, and that involves clicking on this base instruction first. And we're going to use this drop down here. And these are all the columns that are in the GE Cytiva kind of universe, right? And you can use any of these columns to do a plate measurement. I am going to do the HiLoad 2660, let's say Superdex 200. All right, and I'm gonna hit change. All right, and this window that pops up says, hey, these are the default values, and I'm gonna change those default values for the method settings phase to whatever's here. And I'm just gonna hit okay, because that's fine. And then somehow the gradient window popped back up, so I'm just gonna close that again. All right, I just like to be able to see as much of the method as I possibly can here. All right, the next kind of housekeeping thing I'm gonna do is anywhere where it says capital V, capital A, capital R, that's a variable, and I'm gonna get rid of all of the variables except for the flow rate. So the reason I'm doing that is I just wanna make things as simple as possible. You don't have to do this. And the way I'm going to get rid of all these variables is I'm going to click on the button that says VAR. I'm going to click clear, okay, and then change. All right, I just want to point out really fast as well is that I didn't actually change any of the instructions. I just got rid of the variable that would allow me to change it when I start the method. Okay. The next thing I'm going to do then is I'm going to do a pump wash, and I want that to be before the flow, so I'll select the inlet there, and then I'll do pump wash, and I'm going to do Inlet A, and why don't I do that as a variable? Change. All right, so then we have the flow rate, pump wash. All right, we're good there. I'm going to close this method, so we don't need to use anything there. Then the next thing I'm going to do is I'm just going to add a bunch of phases to my method. So I'm going to go here to view, and then I'm going to click phase library, And I'm just going to use the user-defined phase. And the user-defined phase is just an emptied phase. So, like, if you look at it right there, there's nothing in it. So, rename. Okay, get rid of the phase library. All right, so for the column equilibration, we don't have a column valve to change, which, like, with all the other videos I've had to do, we had to do that, but that's fine. Yeah. And then all we have to do then is we have to set a certain length of column equilibration. So we'll do 1 CV. Change. Then for the salt injection, now this is where the magic happens. I'm going to go to flow path and then injection valve, and I'm going to select inject, insert, and then right after that I'm going to do load again and insert. So load is the default position, right? So how this works is that the system is going to read all these other instructions. It'll read this column equilibration, right? And it'll come through here, and then it's going to read these 3 zeros right here, and then it'll read the column ejection valve instruction. And so it'll change the column valve, and then I'm going to change this to 2%. So which of the 2% of the column is 0.02. And then, so let's do this. All right, so the system will read this instruction. It'll change the injection valve to inject. It'll read this 0.02, and it will wait right there until that is finished. And then it will read the instruction after it, which will change the column valve back to load, right? And that will be my salt injection. Really easy. The other thing I want to point out here is, like we were saying earlier, this method will use 2% of a column volume. Well, our column volume is 318 mils. That means we're going to do like 6.4 mil injection. So you're going to have like at least 6 or 7 mil volume to be able to properly do an injection. Maybe 2 of those 5 mil injection loops, like end on end together, or a super loop. Okay. Now that we've done that, the next thing we need to do is really easy. We're just going to finish the run by determining the length of it. I'm just going to do 1.5 CVs. All right, so that's great. We're all done actually writing the method with the text. The next thing we're going to do is save the method. So I'm going to save it here in the training examples folder, and this is going to be Go Plates. Save. And you do want to make sure you have the right system specified. Okay, so the next thing I want to do is I want to save where the result files are going to be, are going to end up. So this is a different kind of save, right? This is the actual chromatogram when it's done. So instead of it being at default home, I'm going to specify the folder, which is going to be that training folder. If your results just disappear, it's because they're in the default home folder. You didn't specify where you wanted to save it. That happens to me all the time. Okay. And then we're going to work our way through the rest of these buttons. So this is the start protocol. I'm going to turn on the variables. I'm not using the fraction collector, so I'm going to turn that off. I can show you scouting in a second. And then the result name and location. Great. That's enough. That's good. All right. So that's it. That's the entire thing of the method that you need. So let's talk about the column for a second. What if your column isn't listed in this list, right? What you do is you make your own columns. Like let's say you have a different, like a column that's from a different company that's not like Cytiva. What you do is you go to Tools and then Column Handling. And then here you can make a new column, and you just click the New button. and you fill this out as best you can. You want to make sure you fill out all these things with a little asterisk here, and then you go to the details button, and then you fill out the hardware diameter and bed height. Those are the two most important things, and you just hit save. I'm not going to do that right now. I actually have an entire video about this, so you can check that out. I'll link all the videos below. So that's if you want, a custom column. And I said this method would work for just about any column. You can change this column. Like you finish this plate measurement and then come back 6 months later, you want to do it for a different kind of column. Well, you can just go here and then select, like, I don't know, the 1660 Cephacryl. Let's do S200, right? Or S300. And we'll hit change. And then this is going to come up, the same window as before that says, hey, here's the old value and this is the new value we're going to change it to. We're going to hit OK. And so now we can use it on a different column. And of course with this column, because it's 1.2 mils, the injection volume is going to be different, right? And then let's see here, scouting. Okay, so let's say we want to do 3 runs in a row just to make sure that the plate measurement we're getting is like the right one, or so we can average it or something. I don't know. With this one, with this column, we're only going to be injecting, 2.5 mils, 2.4 mils every time, right? So we can go over here and we can select scouting. And let's just say we do column equilibration, column type. We'll just do all of them, right? Okay. So the first thing we can do, the really only thing we need to change in this entire thing is the column equilibration, right? Let's add some runs in. Okay, so there's 3 runs. Obviously, because the length of run is 1.5 CVs, all the salt is going to come into the column and then all the way out. It's going to be completely rinsed out. So we only need to do a full column equilibration the first time. So we're going to change this to 0.05% of the column, right? So I'll just speed things up a little bit. Of course, when you change this in scouting, you want to make sure that you change it, like if you change the column here, you want to make sure that the columns are the same. Yeah, they match with scouting. So just keep that in mind. And then, of course, we need to turn on the scouting in the start protocol just so we can see it as we start up. Okay, that's it. I hope this helps you with your purifications. Thank you very much for watching. Leave a comment below. All right, so how do you do a calculation for plates after you've done a run? I'm going to show you in both the streamlined evaluation module and the classic evaluation module. Let's start with the streamlined. I have a file already pre-selected here, which is I did a while ago, but still works. All right, and this is what comes up. Your view might be different, but you're gonna have some curves up here, and what you're looking for is the conductivity curve. And you need to have the curve selection box up, and if you can't find it, you just go to view and then curve selection. And what you'll notice is that there's this f of x on the side, and what we have to do is we have to integrate the conductivity peak. So I'm going to turn off the integration for the UV peak and turn on the integration for the conductivity peak. The other thing is I just really don't like this UV curve here. It's really noisy, and the reason it's so noisy is just because the scale is really, really tiny. So I'm just going to click on this. All right, and you'll notice down here, when you integrate, you get a peak table down here, and so the peak I'm interested in is the one that has the retention time of 70 mils. So right here, that's peak C, but there is no column that tells me what the plates per meter is. So what I have to do is go over here to this little gear, click on it, and select plates per meter, which is right here. And we've talked a little bit about asymmetry, so if you want to turn that on, click this asymmetry 10%. That's the one you're looking for. All right, and this is my result. I have 2,704 plates here, and I have an asymmetry of 1.41. I would say this asymmetry isn't very good. And the thing that's important about plates, just remember, is it's really dependent on your setup. Okay, so we're in the classic evaluation module. The first thing we need to do is open our file, and I have mine pre-selected right here. So I'll just open it. Okay, and your view might look different than this, but the first thing is I've got some curves I don't really want to look at, so I'm just going to get rid of those. I'm going to right click and then go to customize, and I'm just going to turn off all the curves I don't want to see. And the reason the view on each of these curves is weird is because I am remote desktoping. So anyways, I have the conductivity curve here selected, at least I did. Now I do again. And that's what I want to see. So there we go. That's just the curve itself. Now I want to integrate this curve. So I'm going to go over here to integrate and then peak integrate. And what this box on the left here, window on the left here is saying is what curve do I want to integrate? That's conductivity. And what is the resulting peak table going to look like? Which peak table do I want? I want A. And I have integrated this curve once or twice before. And I know that it tries to integrate all these little blips right here. So what I'm going to do is reject some peaks. I'm just going to do the largest curve, the largest peak, and hit OK. And then here is the resulting curve, and it's been integrated. It's at 70 mils. And so you'll notice it's the only peak that was integrated down here, and it actually has the total number of plates per meter already shown. That's the default for this, but it doesn't have the asymmetry. So how I turn that on is right click and I hit customize, and then I can find it down here. So I'm just going to find asymmetry, which is right here. If you don't have the plates, it's this plate height right here, HETP. I'm going to hit OK. And there you can see the asymmetry. There's the plates per meter, and then there's the HETP right there, the plate height. Okay. You'll notice I get the same number of plates more or less, and I think the reason why, let's see, this one's 2,711, and in the other version I had 2,704, and I think that's just because the retention time goes out to a few more decimal places. Okay, I hope that helps.